IO.net airdrop just dropped, and a lot of investors are searching on how to withdraw the IO tokens and make money. Of course, we will discuss that, but let's talk about if IO.net is a good investment first. Looking at the price details of IO.net coin, all I can see is the heavy bullish run. You see, IO.net is just a new crypto project, but the developers on this project are already established and experienced. Not many cryptos get this momentum immediately after launch. For those that want to buy IO.net and wondering if this is a good investment in the future, I am here to tell you that it is. To be honest, I think this is one of the best investment you could do before 2024 runs out. I love this project because of the established developers. It's very high to see an early project get to Binance, but IO.net coin made it to Binance. I see this project just like Notcoin. Well, the last time I checked, Notcoin is doing very well at about $2 billion market cap. I believe IO.net can do the same in month. Forget that IO.net is currently at around $500 million market cap. To me, IO.net is still undervalued because they are a lot IO.net coin can still achieve in 2024. Lastly, IO.net is up at around 30%, and it is trading at $5, with a market cap of $500 million, fully diluted market cap of $4.6 billion, and a 24-hour trading volume of $1.7 billion. Since OpenAI's ChatGPT debuted in November 2022, the intrigue around generative AI and its applications has notably expanded into the cryptocurrency sector, seeking to blend AI with blockchain technology. As demand for AI and machine learning intensifies, there's a notable shortfall in cloud GPU resources, estimated at 2 to 3 times the current global capacity. To address this, crypto projects like IO.net (IO) are emerging to decentralize compute resources, supporting the growing AI industry. Here, Coin Edition explores the prospects of IO.net, including its IO.net, is a decentralized GPU network that emerged at the intersection of cryptocurrency, AI, and decentralized physical infrastructure networks, DePIN. It harnesses underused computing resources to address the global shortage of GPUs. Since its inception in November 2023, IO.net has integrated nearly 19,000 GPUs and over 6,000 CPUs, all of which have met the proof of compute criteria and are ready for use. To expand its capabilities, IO.net has also incorporated 2,000 GPUs from partner networks, such as Render Network and Filecoin. This initiative taps into idle computing power from data centers, cryptocurrency miners, and personal GPUs, significantly boosting available computing resources for AI and machine learning applications. Price forecasts, spanning from 2024 to 2030. IO.net is building an enterprise-grade decentralized computing network that allows machine learning engineers to access distributed cloud clusters at a small fraction of the cost of comparable centralized services. They believe that compute is this generation's digital oil, powering a never-before-seen technological industrial revolution. Our vision is to build I/O to be the currency of compute, powering an ecosystem of products and services that enable access to compute as a resource and as an asset. Modern machine learning models frequently leverage parallel and distributed computing. It is crucial to harness the power of multiple cores across several systems to optimize performance or scale to larger datasets and models. Training and inference processes are not just simple tasks running on a single device, but often involve a coordinated network of GPUs that work in synergy. However, traditional cloud service providers have 2.5x less capacity than the estimated demand in the market from AI/ML companies, making access to distributed computing resources presents several challenges. Some of the most prominent are limited availability. It can often take weeks to get access to hardware using cloud services like AWS, GCP, or Azure, and popular GPU models are often unavailable. Poor choice. Users have little choice regarding GPU hardware, location, security level, latency, and other options. High costs. Getting good GPUs is extremely expensive, and projects can easily spend hundreds of thousands of dollars monthly on training and inferencing. IO.net solves this problem by aggregating GPUs from underutilized sources, such as independent data centers, crypto miners, and other hardware networks like Filecoin, Render, and others. These resources are combined within a decentralized physical infrastructure network, DPIN, giving engineers access to massive amounts of on-demand computing power in a system that is accessible, customizable, cost-efficient, and easy to implement. With IO.net, teams can scale their workloads across a network of GPUs with minimal adjustments. The system handles orchestration, scheduling, fault tolerance, and scaling, and supports a variety of tasks such as pre-processing, distributed training, hyperparameter tuning, reinforcement learning, and model serving. It is designed to serve general-purpose computation for Python workloads, with an emphasis on serving AI/ML workloads. IO.net offering is purpose-built for 4 core functions: batch inference and model serving. Performing inference on incoming batches of data can be parallelized by exporting the architecture and weights of a trained model to the shared object store. IO.net allows machine learning teams to build out inference and model serving workflows across a distributed network of GPUs. Parallel training, CPU-GPU memory limitations, and sequential processing workflows present a massive bottleneck when training models on a single device. IO.net leverages distributed computing libraries to orchestrate and batch train jobs such that they can be parallelized across many distributed devices using data and model parallelism. Parallel hyperparameter tuning. Hyperparameter tuning experiments are inherently parallel, and IO.net leverages distributed computing libraries with advanced hyperparam tuning for checkpointing the best result, optimizing scheduling, and specifying search patterns simply. Reinforcement learning. IO.net uses an open-source reinforcement learning library, which supports production-level, highly distributed RL workloads alongside a simple set of APIs. The IO Cloud allows you to deploy and manage on-demand decentralized GPU clusters. This provides users with access to GPU resources without expensive hardware investments and infrastructure management. IO Cloud democratizes access to GPUs by providing ML engineers and developers the same experience as any cloud provider. IO Cloud leverages distributed resources from a decentralized network of nodes called IO workers. Clusters provide the building blocks of IO Cloud and are fully meshed self-healing GPUs. With IO Cloud, you can leverage a decentralized network of GPUs/CPUs capable of executing Python-based ML code for your AI projects. This platform is natively powered on the Ray distributed computing Python framework used by OpenAI to train GPT-3 and GPT-4 across 300K servers. Key features: a large and cost-efficient GPU cloud on demand with unlimited scalability for AI/ML training inference, smooth integration with IO SDK, effortlessly connect IO networks' GPU resources with IO SDKs distributed. Computing capabilities to create a unified high-performance environment for your AI projects, offering unparalleled affordability, up to -90% cheaper per TFLOP. Globally distributed GPU resources, functioning as the CDN of ML serving and inference, bringing GPUs closer to end users. Natively powered by and battle-tested on the Ray distributed computing Python framework used by OpenAI to train GPT-3 and GPT-4 across 300K servers, offering unprecedented easy framework to scale Python applications at any scale. Future access to IO Model Store and advanced inference features like serverless inferences, cloud gaming, and pixel streaming.